Alam mo na ba kung paano nabuo yung mga heavy elements that tends to the formation of stars? Paano nga ba nabuo ang mga elements na ito, ang mga elementong ito? Kung hindi mo pa alam, panoorin mo ang video mo. Good day! Welcome to Sir Fox Learning Channel. Today, I will present to you one of the first topics in physical science, the formation of heavy elements, the concept of atomic number, and the synthesis of the new elements. Samahan niyo po akong panoorin ang video ito, and hopefully, kung bago ka sa channel na ito, huwag mong kalimutang mag-subscribe at i-hit ang notification bell on para updated ka sa mga susunod ko pong video lessons. Especially kung meron kang kamag-anak, kaibigan na senior high school who are taking physical science for the second semester, this is a right video for him or her. Tara, samahan niyo po akong panoorin ang video ito. As I discussed last time about the Big Bang Theory, how everything has created according to Big Bang, that after how many minutes? It was 3 minutes in which atoms, particles, which they called it as the protons, neutrons, and electrons, has formed. And afterwards, after several times, around 300,000 years, doon pa lang nagkaroon ng attraction si electron and proton, which tends to the formation of light elements, which was hydrogen and helium and other light elements. Okay? Today, I would like to present to you the formation of heavy elements. How did the heavy elements form? Like the light elements, according to Big Bang, it was formed after 300,000 years when protons and electrons, or they call it quarks, attract to each others, forming the light elements. So this time, we will find out how heavy elements was formed. But before that, let us have first a values formation. This is all nothing of all my preparation, especially to all my learners in grade 11 who are taking physical science, if your heart is not in the subject. Paul says to the Colossians that whatsoever ye do, do it heartily as to the Lord and not unto men. Distance learner, if you really thinks that you are a learner, you should do your best how to learn. And I, as your teacher, may be a guidance, a signage to guide your way. Okay, happy learning. and welcome again to Surfax Learning Channel. Our learning target for these lessons, actually, this represents for week 1 sa lessons in physical science rather, of our first learning target for the topic how heavy elements has formed. First, to explain stellar nucleosynthesis. Later, we will do that. And hopefully, you too, after watching this video, describe the different stages of life cycle of stars, how life cycles of stars do, cite the different heavy elements formed in each stages of star cycle. So, in your activity number 1, to my learners in physical science, you are asked there to state your own life cycle as to the star. Okay? So, this video may help you, most probably. Now, scientists believe that the formation of universe began through the explosion of primordial atom, which happened approximately 13.7 billion years ago. Primordial atom. Scientists. But later on, they conclude that there's no explosion happened. Instead, according to Edwin Hubble, there is a expansion. Constant expansion. According to Edwin Hubble, as he states or he studied the Big Bang theory. So there was no explosion happen, but expansion. But around 13.7 billion years ago. Okay? So if we could still recall, an atom-like particle which was heated or hit by, not heated, hit by a cosmos is an energy, and as it hits, that atom-like particle tends to expand and expand and expand, and up to now still expanding according to Edwin Hubble. Now, right after Big Bang, around 300,000 years, protons and neutrons tends to attract. Hey, mas na sila. Wow, ang attractive ka pala. And they combine and form light elements, which was hydrogen and helium, through the process of Big Bang nucleosynthesis. Alright? So pag sinabi nating nucleosynthesis, attracts within the nucleus. And other like elements such as lithium, beryllium, were also formed during this process. The process continuously prevailed. Prevailed? What a word, prevail. Not for science, I think. However, stellar nucleosynthesis stated that since stellar means star and formation of elements in the center of the star, is called stellar nucleosynthesis. So, meaning to say, itong stellar nucleosynthesis referring to or this refers to the study on how heavy elements, how stars are being formed. Carl Sagan said that we are made of star stuff. This process creates elements within stars by combining the protons and neutrons together from the nuclei of light-year elements. So heavy elements created and formed by combining protons and neutrons in the nucleus from the lighter elements. Siyempre, hindi ka naman agad magsisimula sa malaki ka agad, di ba? It will always start from a small and you become bigger and bigger and bigger and bigger. Fusion inside stars transforms hydrogen into helium, heat, and radiation. So by fusion, what do you mean by fusion? To fuse is to combine, to heat, to interact or attract. Heavier elements are created in different types of stars as they die or explode. Ayun na pala eh. May sagot na agad tayo. Paano na-form yung heavy elements? When the star was formed and died, heavier elements, according to stellar, has formed. So in the process, excuse me po, in the process, may tinatawag po tayong, in the process of formation of star, average star. The average star is unable to generate heat when it runs out of hydrogen and its core leading to its construction and expansion. It cools down and glows red. The helium fuses into carbon. The star is now red giant. The red giant star becomes exhausted of nuclear fuel, and outer material is blown off into space, leaving the inert carbon, and the remnant is known as white dwarf. So this is how the process, the transformation of an average star. Giant cloud of gas and dust known as nebula. It is formed from nebula due to the gravity that pulled hydrogen gas together until it spins faster and faster and becomes ignite. A protostar rises. Protostar rises. Main sequence star starts to form when nuclear fusion occurs to the core of the star. It begins to contract, glow, and become stable, and hydrogen is converted into helium. So, theoretically stated here how average stars are formed. This is said to be the remain of the white dwarf that cooled down and no longer emits light and heat, the hypothetical black dwarf. So that's how average star is formed. And, syempre, kung may average, merong massive. Massive star believe that neutron star is formed from supernova explosion. This is also the smallest star. So taken from the smallest star. Smallest but massive. Explosion of star of supernova releases large amount of energy. Yun lang. Because of that, elements are dispersed into the space. Yun yung paniniwala ng science eh. Black hole is a region in space where gravity is too strong that no matter can escape from it. A more massive main sequence star evolves, cools, and expands faster than low mass star and will turn into red supergiant star. The largest known star is the carbon fusion still occurs in oxygen form. Okay? Now, how stars are formed? Though based on the description of average and heavy stars is already it has already stated how stars are formed. But let's proceed how. By nuclear fusion. When we say nuclear fusion, it is interaction, reaction within the nucleus. A combination of nuclei to form heavier one among heavy elements. So, as what I've said a while ago, that the process of attraction, since electron and proton attracts up to the point na nagkaroon ng light elements, and these light elements did not stop but continually attracts with proton, neutron, and other elements and isotopes to form heavier elements through the process of nuclear fusion. Meaning to say, fusion in the nucleus. Kaya nuclear fusion, fusion in the nucleus. Ano ba yung nucleus? The central part of an atom. Hopefully, alam nyo na yan. I know, grade 9 pa lang or grade 7 if I'm not mistaken. Ituturo na sa inyo yan. Nasa lesson nyo na yan. Nuclear fusion stars is slightly different. Here, ito as stated in the example here, can I use a pointer? If I could. Pointer option here. Ayan, laser. Step 1. So, this is the step 1, the step 2, and step 3. Nandito naman yung discussion per step. Nuclear fusion in stars, slightly different. 2 protons. Nasaan ba dyan yung protons? Ito. Of hydrogen fuse. So, these protons fuses together with 1 proton converting to a neutron to form deuterium. This is it now. The deuterium is one of the isotope of hydrogen. I will show you later kung ano yung itsura ng deuterium. Chemical formula ng deuterium. The deuterium, this deuterium fuses with another proton. So ito si proton. Ito pala ito. Itong si deuterium fuses with another proton. So, fuses with another proton to form helium atom, which is helium-3. Sir, di ba ang helium ay 4 yung kanyang number of protons? Yes, but may isotope ang helium. Ano ba yung isotope? Atom with the same number of protons but different number in neutron. Okay? And 2 helium-3 nuclei fuses to form a stable helium atom. Ito na po yun. Since the mass of the products is slightly less than the mass of the reactants, some mass has been converted into energy. Okay? Kaya may makikita kayo diyang mamaya may example ako doon na may gamma rays. Yung mga gamma rays na yon is the energy. released energy. In heavier a mass starts, the helium nuclei can fuse to form carbon, and these elements can even fuse heavier elements right up to iron. So yung helium, pwede siyang makapag-fuse, makapag-interact, attract, even up to iron. Our sun will produce very few elements heavier than helium. Let's have these proton-proton chains. So, yung example natin kanina is already a proton-proton chain reaction. So, this is the fusion of deuterium and tritium. Ano ba yung deuterium? Ano yung tritium? Deuterium is an isotope of hydrogen, tritium as well. Once these isotopes will fuse together, it will also form a helium. So another way of how helium has created by fusion. Okay? Kapag si deuterium and tritium fuses together, it will produce a helium atom, stable helium atom, and will release as well energy and another neutron. So these are the isotopes of hydrogen atom. This is protium. Ibig sabihin, mayroon siyang 1 proton and 1 neutron, kaya protium. Ito naman is the deuterium, deuterium. Mayroon siyang 1 proton sa kanyang nucleus. Remember, the nucleus is the central part of the atom. Inside the nucleus is positive charge and its neutron. However, electrons rotates around the nucleus. And the other one here is the tritium or triton in other means. Ibig sabihin, meron siyang 1 proton and 2 neutrons. You will notice here, you have the same protons but different number of neutrons. Kaya tinatawag itong isotopes of hydrogen. Still hydrogen, though magkakaiba sila ng size or number of neutrons. Ano ba yung neutrons? Neutral charge of positive, neutral charge of negative. I want to show you how, this video rather, pero I think hindi naman na kailangan. Showing here, sige, pakita pa rin natin. For your sake. For your sake. Okay. Anong nangyari? I want to show you this. So nuclear fusion process by Ellin means process which involves nucleus. Nuclear fusion means 2 or more entities coming together or meaning merging together. However, nuclear fusion can be defined as the nuclear reaction in which lighter nuclei are combined together to form heavier product of nuclei with the release of enormous amount of energy. For instance, helium fusion. Mass of heavier and mass of the lighter, and the fusion of the lighter elements produces heavier nucleus. And you will notice energy is conserved in this process. In the deuterium, ayan, how deuterium has produced. And that deuterium will be attracted with hydrogen to produce helium-3, and that helium-3 fuse with another helium to create a stable helium, like what I said a while ago. Okay? So much for that. Let me choose again a pointer option laser pen. Okay. So nuclear fusion, that was nuclear fusion. How nuclear fusion happens. Okay? So another examples here, the fusion which was shown in the video actually, the fusion of two hydrogen atoms, most probably protium, will lead to deuterium and has an energy release. And once this deuterium fuses with another hydrogen atom or protium, will have a helium-3. And this helium-3, once this fuse with another helium, will create a stable helium atom and another protium. And this helium-3 as well, once will fuse with another hydrogen or protium, will produce as well a stable helium atom. So remember, yung nasa taas is atomic number. Of course, yung letters are the symbols. And in an atom, you have the atomic weight sa periodic table. Kindly check that if you have, and you must have. Stated naman lahat po yan doon. Again, the three isotopes of hydrogen, protium, deuterium, and tritium. Symbolizes by P, ibig sabihin 1 proton. Ito, P pa rin, pero may neutron na. Ito, 1 proton, 1 neutron. You will notice, nasa center siya, ibig sabihin, nasa nucleus yan. Another isotopes of hydrogen just showing you. Yan pa rin. Ang protium, meron siyang 1 proton, walang neutron, pero meron siyang 1 electron. Ang electron, sir, nasan yung electron? Nasa labas, umiikot. Deuterium, meron siyang 1 proton, 1 neutron, 1 electron. Ang tritium, 1 proton, 2 neutron, 1 electron. And these are what? These are what? Again, isotopes of hydrogen. Perfect. Of course, kung ang hydrogen, merong mga isotopes, mayroon din ang helium. There are 9 isotopes of helium with different numbers of neutrons. Take note, isotopes are those atoms with different number of neutrons but the same number of protons. Oh, just take a look at this, the different isotopes of
helium. Helium 1, 2, 3, 4, 6, 8, 7, 5, 8, and 8. Okay? So the different isotopes of helium. Another representation of the isotopes of hydrogen. Nuclear fusion takes place in the core of star. Nasa core ng star. According to stellar uh, stellar synthesis. Fusion combines the nuclei of hydrogen atoms into helium. When two particles fuse, energy is released. Paulit-ulit tayo dyan. Hopefully, clearly stated na to. Kasi paulit-ulit nga na dinidiscuss natin. Na, again, this is an atom. Definitely, let's say, kanina, hydrogen fuses naging deuterium and will have an energy release and so on and so forth. This energy given off by the nuclear power makes the sun and all stars shine brightly. Brightly. Okay. As the main sequence star glows, hydrogen in the core is converted into helium by nuclear fusion. Look at this again. The deuterium and tritium fuses together which creates a helium atom, a stable helium. Paano natin nasabing stable siya? Dahil meron siyang dalawang proton which is the blue ball here and nucleus, a neutron rather, an energy release. Of course, another process how stars are formed is the tri-alpha process. In this, you will see here, bakit tinawag siyang tri-alpha? Kasi, wait lang, balik natin to. Balik ka sa pinanggalingan mo. Yan. Kasi, apat yung helium na involved. Apat. Tatlo ang helium na involved. Kaya nga tri-alpha eh. Bakit alpha? Helium naman. Kasi, ang alpha particle has the same charge with the helium atom. Got it? Ang alpha particle has same charge with the helium atom. Okay? So, isang helium, pangalawang helium, pangatlong helium. So, tri-alpha process. Once na yung helium na to fuses with this another helium, will results or will have the product of beryllium and have an energy release which is the gamma ray. So take note, the pink here is proton, the blue neutron, and this is gamma ray. And this beryllium will fuses with another helium, probably, hindi lang probably, definitely results to carbon-12. So ito na po yung results niya and has an energy release here. The tri-alpha process. So that's how stars in a nucleosynthesis has formed. Oh yeah. Pause muna dahil yung ating screen. Okay? Yan. Moving. The tri-alpha process happens in red giant star once they leave the stage of main sequence star, and this is how 3 helium are converted into carbon. Another thing is the proton-proton chain. A star accumulates more massive and continues to grow into red supergiant. Alpha particle fusion happens in its core and create more heavy elements until iron. And this is known as the alpha ladder process. The alpha ladder process. Paano nga ba naging alpha ladder process? So you have here helium, combined with another helium will produce carbon, and combined with another helium will produce oxygen, combined with another helium will produce neon, combined with another helium or fuses with another helium will produce magnesium, uh, fuses with another helium will produce silicon, silicon ba yung Si? And fuses with another helium will produce sulfur, argon, what is Ca? Calcium, Ti, chromium, iron, nickel, and so on and so forth. Ano ba yung Ti? Okay? That's what we call as the ladder, alpha ladder process. The process of fusions of different of helium to different atoms forming heavier ones. How do elements heavier than iron form? As the energy at the core of the star decrease, nuclear fusion cannot produce elements higher than iron. Pag nag-decrease yung energy dun sa core ng star, hindi siya makakapag-produce ng elements heavier than iron. At different pathway is needed para ma-produce, ma-create yung heavier elements to be formed. Ano kaya yung pathway na yan? At yan ay tinatawag na neutron capture. Ano kaya ang neutron capture? So let's have this example. Let's say ito po ay neutron. This neutron will be captured by this element, by this atom rather, and will produce this one. So paano natin nasabi na ito yung naging product? Ayan na. Again, sa chemical equation, mayroong product and reactants. This is our reactants and this is our product. Dito, nakita po natin, mayroon lang siyang ilang proton. 5. Tama? Nung nagkaroon ng fusion, nung na-capture nitong nucleus, nitong atom, si proton here, nagkaroon siya ngayon ng 6 na proton. A neutron capture, a neutron is added to a seed nucleus. That's neutron capture. When neutron is added to a seed nucleus. So you will notice here, this alone proton, selfie proton, might be a sad proton dahil alone niya was captured by this happy family of protons in the nucleus and created a big one, nucleus. That's how neutron capture happens. Wow. Now, a neutron capture can be slow or rapid. Pwede siyang mabagal, pwede ring mabilis. Tanong, kailan natin masasabi na slow yung neutron capture? Anybody? At kailan naman natin masasabi na rapid ang neutron capture? Anyone from our audience? Oh, may audience. The S process. Ang S is slow. Para hindi masyadong harsh, di ba? Pag sinasabihan mo yung kaibigan mo na ang slow mo naman, para hindi maging harsh, sabihin mo na lang, ang S mo naman. Ibig sabihin, ang slow. Ang slow neutron capture or slow process happens when there is a slow rate of capturing neutron while there is a faster rate of radioactive decay, hence increasing of proton by neutron capture. Example, this bismuth capture one neutron, became another bismuth, an isotope of bismuth. And this bismuth, an isotope of bismuth, which is 210, capture another proton, will become, will become polonium, and so on and so forth. Ito, the bismuth captures neutron producing bismuth 210. And this bismuth decays at naging polonium. If I'm not mistaken, polonium yung PO by beta decay. Ito, beta decay. Asan na ba yung beta decay? Asan na yung beta decay? Wala. Hindi napakita. Ang hirap kasi magkuha ng picture. But by beta decay. And this polonium turns to decay as well. At naging lead by alpha decay. So bakit naging slow yung kanyang process? Ang pinag-uusapan po natin, decay. And to decay an element ay hindi po yan isang oras lang. Okay? It will take time how to decay an element. Hindi lang yan isang araw, isang oras, it will take a long time to decay. Kaya slow process. Saka, isang proton lang. After that long period of time of decaying an element, isang proton lang ang mapapala mo. Diba? However, a rapid process or our process means that there is faster rate of capturing neutron before it undergoes radioactive decay. Thus, more neutrons can be combined in the nucleus. This is what happens in a supernova, forming heavier elements than iron with the process known as supernova nucleosynthesis. Okay, example of this is the iron here with another iron isotopes. So bombarded with 3 neutrons and creating into a cobalt. Oops. Oh, second topic pa lang. The explosion of stars or supernova is believed to be the source of other elements heavier than iron. Explosion of supernova. So this is might just a theory, but they believe, science believe, yung formation of heavier elements is because of the explosion of supernova. During the explosion, these heavy elements are dispersed into the space. So, na-disperse. Aside from the hydrogen and helium in space, other evidence of star formation is the energy emitted during nuclear reaction, which includes ultraviolet, infrared, X-ray, radio wave, and microwave. Okay? So how heavy elements has formed? When the supernova explodes, according to stellar nucleosynthesis. Therefore, our first problem in the learning target probably answered. Up next, the concept of atomic number, which led to the synthesis of new elements in the laboratory. So though we will not have a laboratory, kasi virtual nga eh. But our learning target here is to explain how the concept of atomic number led to the synthesis of new elements in the laboratory and identify the different elements formed after the process of synthesis and realize the importance of the atomic number in identifying the new elements which identified in the periodic table. Let's describe first, we could still recall how the Greeks and ancient Greeks describe atoms. So, paano nila discover yung atoms? Balikan po muna natin dito. Oh yeah, pointer. The R1. Oh, come on. Oh, wait lang ha. Kaka-pointer eh. Yan. Una nga mag-pointer. Ayan. Investigating atoms and atomic theory. Students should be able to describe. So, wag na. The history of atomic theory and different atomic models. So, first, let's determine first of who are these people in the screen. Sino-sino sila? Natatandaan nyo ba sila? Turo nyo at sabihin kung sino sila. Wala. O, tukuyin na natin. This one is Democritus, around 400 BC. This is a Greek philosopher who began the search for a description of matter, which led him around 2,400 years ago. Along 2,400 years ago. Sabi niya sa sarili niya, ang bagay ba pwedeng ma-divide into smaller pieces? Or could a matter be divided into smaller and smaller pieces forever? Or was there a limit to the number of times a piece of matter could be divided? So, ginawa niya ng problema yung kanyang sarili. Tinanong niya yung sarili niya, could a matter be divided into smaller and smaller pieces forever? Magandang tanong yan ah. Susolusyonan ko nga. So that's how Democritus started on his search for how matters what are the composition of matters. For him, Matter could not be divided into smaller and smaller pieces forever. Hindi pwedeng mahati yung matter into smaller and smaller and smaller forever. Eventually, sabi niya, the smallest possible piece would be obtained. So, pwedeng huminto yan dun sa pinakamaliit. And this piece would be indivisible. Tinawag niyang indivisible. And he named the smallest piece of matter as atomos. Meaning, not to be cut. For Democritus, atomos were small, hard particles that were all made of the same material but were different shapes and size. Atomos were infinite in number and always moving and capable to join together. That's how Democritus described his atom composition that compose matter. This theory was ignored and forgotten for more than 2,000 years. Bakit kaya? Yung kanyang teorya na-ignore, nabaliwala. At 2,000 years na hindi na-highlight. That's sobrang haba nun. Dahil sa mga sikat na ito. Si Aristotle and Plato. The eminent philosopher at the time of Aristotle and Plato had more which are more respected, ultimately wrong, Democritus. Dahil sa respected itong dalawang ito, kaya for 2,000 years nabaliwala yung pinaghirapan ni Democritus. Now, Aristotle and Plato favored that the earth, fire, and air, and water approach the nature of matter. Their ideas held sway because of their eminence as philosophers. The atomos idea was buried for approximately 2,000 years. So ito po yung timeline natin. Si Democritus nandito. So for 2,000 years na namayagpag itong dalawang sikat na scientists, Aristotle and Plato, insisting or teaching their ideas about matter, which is composed of earth, fire, mga elemento ni sa Encantadia. And afterwards, around 18th century, an English chemist, John Dalton, performed number of experiments that eventually led to the acceptance of ideas of atom. So dahil kay John Dalton, dahil sa mga experiments niya, nagkaroon ulit ng ideas of atoms. So ito yung teorya ni John Dalton. Sabi niya, all elements are composed of atoms. And atoms are indivisible and indestructible particles. And atoms of the same elements are exactly alike. And atoms of different elements are different. And compound are formed by the joining of atoms of two or more elements. So nagkaroon siya ng panibagong teorya. At itong teorya niya ni John Dalton became the foundation of the modern chemistry. So at least nasapawan na yung mga filosofiya ni Aristotle and Plato because of the experiments na ginawa ni John Dalton. Around 1897, 18th century pa rin, English scientist Joseph John Thomson provide the first hint that an atom is made of even smaller particles. Sabi ni Thomson, as he proposed a model of an atom that na tinawag niyang plum pudding model. Na sa kanya, atoms were made from positively charged substance with negatively charged electrons scattered about like racing in the pudding. So ito po yun. Ito yung atom ngayon ni Thomson. Sabi niya, made of positively charged substance with negative like raisins of pudding. Okay? Thomson's model was created by using a passage of electric current through a gas in which current passed through the gas and it gives off rays of negatively charged particles. So ito yung ginamit niya. And he was surprised because atoms of the gas were unchanged. Where had the negative charge come from? So yung atom dun sa ay nagbago pero saan daw nanggagaling yung mga negative charge? So ito ngayon naging conclusion ni Thomson. Atoms or negative charge came from within the atom. So negative charge ang galing sa atom. A particle smaller than the atom had to exist. Atom was divisible. So sabi niya may mas maliit pa sa atom na nag-exist. Pero hindi niya alam kung ano yun. Atom was divisible. Divisible na yung atom. And the negatively charged corpuscles, today known as electrons. So yung mga negatively charged, sinawag niyang corpuscles. Since the gas was known to be neutral, having no charge, he reasoned that there must be positively charged particles in the atom. But, hindi niya mahanap. Nasaan kaya yung positively charged? Alam ko may positive, pero di ko alam kung saan dyan sa atom. So that is J.J. Thomson or Joseph John Thomson. Around 19th century, 1908, Ernest Rutherford uses a gold foil experiment. He was an English physicist and has a hard work on the experiment that seemed to have little to do with revealing the mysterious atomic structure. According to Ernest Rutherford, in his experiment, by evolving a firing as a stream of tiny positively charged particles at a thin sheet of gold foil, around 200,000 atoms stick. So ito po yung result ng kanyang experiment. Most of the positively charged, so gumamit siya ng alpha rays, positive charge, pinatama niya dun sa gold foil. And then, sabi niya sa kanyang observations, most of the positively charged bullets pass right through the gold atoms in the sheet of gold foil without changing course at all. However, some of the positively charged bullets, however, did bounce away from the gold foil or gold sheet as if they had hit something solid. And he know that positive charge repel positive charge. So, unti-unti nang nagkakaroon ng klaro yung atom. Dahil maingay yung aking cellphone. Okay? Ayan po yung experiment ni Ernest Rutherford. This could only mean that the gold atom in the sheet were mostly open space. Sabi niya, atom were not a pudding field. Kinontra niya si Thomson with positively charged material. And he conclude that an atom had small dense positively charged center that repelled his positively charged bullets. So, si Ernest Rutherford pala yung nag-discover ng nucleus. Tinawag niya itong nucleus. Taken for that, Ernest Rutherford discovered the nucleus of an atom because of this gold foil experiment. The nucleus is tiny compared to the atom as a whole. Ito po yung model ni Ernest Rutherford. So you have here the nucleus which filled with the positively charged, kaya daw nagkaroon ng nag-repel, nag-bounce off. However, the negative charge surrounds the nucleus, which is scattered outside the nucleus. But around 1913, a Danish scientist, Niels Bohr, proposed the improvement of this model. He placed each electron in a specific energy level. So nilagyan niya ng mga energy level. Kaya meron na kayong orbitals, meron na kayong electron configuration, kagagawan po yan ni Niels Bohr. So according to Niels Bohr, electrons move in different orbit around the nucleus, much like planets that circles the sun. These orbits or energy level are located at a certain distance from the nucleus. And lately, wave model has proposed. The wave model, which is today's model, based on the principle of wave mechanics, according to this theory of wave mechanics, electrons do not move about an atom in a definite path like planets around the sun. In fact, it is impossible to determine the exact location of an electron. The probable location of an electron is based on how much energy the electron has. And according to the modern atomic model, an atom has a small positively charged nucleus surrounded by the large region in which there are enough electrons to make an atom neutral. An electron, to sum it up na. For Democritus, atom is indivisible. For John Dalton, atom is indivisible. For J.J. Thomson, atom has an electron. For Rutherford, atom has an electron and nucleus. For Niels Bohr, atom has an electron, nucleus, and electron cloud. Who do you think proposed a wave model of atom? Who do you think this person? It was Erwin Schrödinger. Now, as we go along, the atomic number is the number of protons, positively charged particle in an atom. In 1913, Henry Grain Jeffreys Moseley, which was an English physicist, demonstrated that the atomic number of the number of protons in an atom determines most of the properties of an element. In 1919, Rutherford successfully carried out the nuclear transmutation reaction, which is a process of transforming one element or isotope into another element. But around 1925, there were 4 unknown elements in the periodic table that corresponds to atomic number 43, 61, and 85, and 87. And elements with atomic number 43 and 85 were synthesized using particle accelerators. The particle accelerator is a device that is used to speed up the protons to overcome the repulsion between the protons and the target atomic nuclei by using magnetic and electrical fields. And it is used to synthesize new elements. Elements with atomic number greater than 92, like of uranium, are called transuranium elements. They were discovered in the laboratory using nuclear reactors or particle accelerators. Dmitry Mendeleev, created a classification of elements based on their atomic weight. He found out that the organizing elements at the time by their calculated weight demonstrated a periodic pattern of both physical and chemical properties such as luster, physical state, reactivity of water, and others. Moseley was an English physicist. In his experiment demonstrated that the major properties of an element are determined by the atomic number, not by atomic weight. Kinontra niya si Mendeleev. And firmly established the relationship between atomic number and the charge of the atomic nucleus. So in 1913, he used Rutherford's experiment in fighting to advance the understanding of the elements and solve the problems with Mendeleev's periodic table. And mostly notice that shooting electrons at elements caused them to release X-rays at unique frequencies. He also noticed that the frequencies increase by a certain amount when the positive charge of the chosen element was higher. By arranging the elements based on the square root of frequency that they emitted, he was able to arrange the elements that approximates the observed properties as proposed by Mendeleev. He also proposed that the element atomic number or place the periodic table was uniquely tied to their positive charge or the number of protons. And this discovery allowed for a better arrangement of the periodic table and predicted elements that were not yet discovered. This method, or his method of identifying elements by shooting electrons and looking at X-rays became a very useful tool in characterizing elements and is now called X-ray spectroscopy. He uses X-ray spectroscopy to determine the atomic number of an element. By bombardment, a beam of electron to different elements measured their X-rays spectral lines. And these results clearly showed that frequency of X-rays given off by an element was mathematically related to the position of the element in the periodic table. And frequencies is proportional to the charge of the nucleus or the atomic number. When the elements were arranged according to their atomic numbers, there were four gaps in the table. The discovery of nuclear transmutations. Around 1919, Ernest Rutherford successfully carried out the nuclear transmutation reaction, a reaction involving the transformation of one element into or isotope into another element. The first nuclide to be prepared by artificial means was an isotope of oxygen, around 170, and it was made by Ernest Rutherford in 1919, bombarding nitrogen atom with alpha particles. However, both alpha and atomic nuclei are positively charged, so they repel each other. And therefore, instead of using fast-moving alpha particle in synthesizing new elements, he bombarded with neutron or neutral particles in particle accelerators. And James Chadwick discovered neutron in 1932 as a previously unknown neutral particle produced along in carbon-12 by the nuclear reaction between beryllium and helium. And this is now start with the discovery of the missing elements by Ernest Lawrence which was able to synthesize elements with atomic number 43 using linear particle accelerator. And in 1940, Dale Corson, Mackenzie, and Emilio Segre discovered element with atomic number 85, and so on and so forth. Marami pa po. The synthesis of the elements. The invention of the cyclotron paved the way for artificial transformation of one element into another. The light energy particles produced by the cyclotron produce heavier nuclide upon hitting heavy target nuclide. While Big Bang nucleosynthesis, the oldest stars in the galaxy are different or deficient in element heavier than helium. Oh yeah. So in a chemical evolution of the universe, low mass stars synthesize new helium, carbon, oxygen during main sequence of RGB or HB or AGB phase. These newly produced elements are brought to be surface via convection and redistributed via stellar, and so on and so forth. In chemical evolution too, for more massive stars, equilibrium fusions reactions produce elements all the way up to iron. Chemical evolution 3, about the trans of iron elements, in which equilibrium fusion reactions of light elements don't proceed past iron because of iron location at the peak of the curve of binding energy. So you will have your performance task: writing, share, record, and sum it up, Venn diagram, concept map.
Ano namang napakahalagang konsepto ang napag-aralan po natin. First lesson in physical science, and looking forward for more lessons to create in this channel. At kung bago ka sa channel na ito, please subscribe and hit the notification bell for more updates. Thank you and happy learning, everyone.